All right, so this is problem number 1 for my week 6 video explainers. So basically this has to deal with a car colliding with a wall, and it deals with two conditions. The first one being if the person has some form of restraint, being like a airbag or a seatbelt, and the other one with no restraint. So I can just read it in the context of the problem here. So in the event of an impact, the passenger compartment decelerates over a distance of about 1 meter as the front of the car crumples. An occupant restrained by seatbelts and airbags decelerates with the car. By contrast, an unrestrained occupant keeps moving forward with no loss of speed until hitting the dashboard or windshield. So I just kind of drew these two scenarios, one being with a restraint and one being with no restraint. So the initial and final position are going to be different in both conditions. So in the first condition with the restraint, the person's going to the crumple zone is going to decelerate over a longer period of time, or like a longer area. And for the other condition with no restraint, it's only going to be 5 millimeters as opposed to 1 meter with restraint. So to get the acceleration over this time, I just used this equation of motion, and then isolated the acceleration. So once I plugged in the final velocity, which was 0 meters per second, because at the end they're just hitting the wall, and the initial velocity, they're going 15 meters per second. So the final position, that total is going to be 1 meter. So once I plugged in all those variables, I got an acceleration of negative 112.5 meters per second squared, and that makes sense because it's a negative acceleration. And then I plugged that back into the force to get the net force on the person, and to keep in mind it was 60 kilograms for the mass, and the acceleration from the previous problem or the part was negative 112.5 meters per second squared. So that total net force is going to be negative 6,750 newtons. And the second part is going to be pretty similar, except that distance they're covering is 5 millimeters as opposed to 1 millimeter or 1 meter, just because they don't have a restraint. So that area of deceleration is going to be shorter. So it's going to be the same. The final velocity and initial velocity are going to be the same. However, that total displacement is going to be 5 millimeters, or in this case, 0.005 meters. So just like in the first part, you plug everything back in to that equation, and you get so this is an acceleration of negative 22,500 meters per second squared, and plugging that back to get the net force is going to be obviously a very large number. You can see it right here. And the main takeaway from here is that it's going to be much larger than the force with the restraint. So it just goes to show with having no seat belts or no airbags, the net force on the individual is going to be much larger, just because that area of deceleration is going to be a lot smaller. The car's going to have a lot less of an area to slow down over. And this just kind of covers into the context of what we've been doing so far. Just has to deal with like more stuff about like linear dynamics, just looking at relationships between like acceleration and force, and tying everything kind of like that in together. And I guess just like one tricky part in here was knowing the signs of the of each variable, whether that be the like accelerations or whatever, and just making sense of it and realizing that why it would be in a negative acceleration, and kind of just interpreting each value. But otherwise it was pretty self-explanatory, and drawing a diagram really helps.